Now we are going to see the opposing force acting on M2. So first we have to draw the free body diagram. So the components which are connected or basic elements which are connected to the M2 are, it is having a spring K, it is connected between M1 and M2, a dashpot B which is connected between mass M1 and M2, and friction of the mass M2 and the opposing force due to this mass M and the applied force F of t. So first we are going to see the opposing force due to this M2 itself. So it is nothing but M2 into d square, the displacement due to the applied force F of t is x. So Fmt is nothing but M2 into d square x by dt square. Then due to Fb2 is nothing but b2 into dx by dt. Then opposing force due to B, that is dashpot connected between mass M1 and M2 is Fb is equal to b into d by dt of x1 minus x2. So while considering the mass M1, we have written as x1 minus x. So here we are considering M2, so we have to write it as x minus x1. Similarly, the spring, opposing force due to spring K. So Fk is equal to K into x1 minus x minus x1. Here also you have to consider x first, because in mass M2 the displacement is x. So K into x minus x1. By Newton's law, the applied force is equal to opposing forces. Here the opposing forces are Fm2, Fb2, Fb and Fk, and the applied force is F of t. Now we are substituting the values of Fm2, Fb2, Fb and Fk and the applied force F of t. Then we are going to find the Laplace transform. Now the Laplace transform of d square x by dt square is nothing but s square into x of s. So M2 into s square of x of s. So the Laplace transform of dx by dt is nothing but s into x of s. So b2 into s into x of s. Then b into d by dt of x minus x1 is nothing but b into s into x1 of s, x of s minus x1 of s, plus k into x of s minus x1 of s is equal to f of s. So from these terms you are calculating, or you are taking x of s common. So we are taking x of s common from this M2 s square x of s and b2 s x of s plus b s x of s plus k x of s. From these terms you are taking x of s common. From the other terms you are taking x1 of s common. After that, instead of this x1 of s, already we have found out the value of x1 of s by applying the Newton's second law in mass M1. By applying the Newton's second law in mass M1, you have calculated the value of x1 of s. So in the place of x1 of s, we are substituting that value. Then after substituting this value, our aim is to find the transfer function. What is here? What is the output? Output is nothing but x, and the input is nothing but f. So we have to find out x of s divided by f of s. So from this we are taking x of s common. From these two you are taking x of s common, and then we are going to find x of s divided by f of s. Okay, here you are taking LCM. So here you are taking LCM, that is you have to multiply the denominator here and they are taking it common. Then after that we are going for simplification and we are getting x of s, and we are getting x of s divided by f of s is equal to m1 s square plus b1 plus b into s plus k1 plus k divided by m1 into s square plus b1 plus b into s plus k1 plus k into m square m2 into s square plus b2 plus b into s plus k minus bsk plus k the whole square. Okay, so this is nothing but the transfer function. So finally we are going to write the result. First we are writing the two differential equation what you got for mass m1 and mass m2. After that we are writing the transfer function. So we have completed the problem. What you have done, initially we have found out that transfer functions for the given system, mechanical translation system. Then we have found out that we have calculated the transfer function. Okay. Next we are going to see one more problem. Determine the transfer function y2 of s divided by f of s of the system shown in the figure. So this is the given figure. So we have to find the transfer function. So here you are having two mass m1 and m2, and to the mass m1 you are applying a force of f of t. Okay. Due to the application of this force f of t, this m1 is having a displacement of y1 and m2 is having a displacement of y2. Okay, and due to this applied force, opposing force will be acting on this mass m1 and mass m2. So first we are going to draw the, so here what is applied input is applied force f of t. So Laplace transform of f of t is nothing but f of s. Then here the output is nothing but y1. So Laplace transform of y1 is nothing but y of s. So watch this figure. You are applying this f of t. Due to that, this displacement y1 and y2 is occurring. Here the output is nothing but y of y2. Okay. So Laplace transform of f of t is nothing but f of s, and Laplace transform of y of 1 is nothing but y1 of s. Laplace transform of y2 is nothing but y2 of s. So first we are considering the mass m1. So in mass m1, a spring k1 is connected. So the opposing force due to this spring k1 is nothing but capital K1 into the displacement here is y1. So k1 into y1. A dashpot which is connected between mass m1 and one end is fixed. So fb is nothing but capital B into dy1 divided by dt. Okay. Now the opposing force due to the mass m1, it is nothing but f m1 is equal to capital M1 into d square y1 divided by dt square. Then we are having a spring K2 which is connected between M1 and M2. So Fk2 is equal to K2 into y1 minus y2. Okay, these are the opposing force which is acting in mass m1. So in mass m1 you are applying a input force that is nothing but f of t. It is nothing but the applied force, and this fk1, fb, fm1 and fk2, these are the opposing forces. Okay, similarly in m2 the opposing force is due to the m2 is nothing but fm2 is equal to d square. Here the displacement is y2, so d square y2 divided by dt square. Then a spring is connected between m1, m2 and m1. So fk2 is nothing but K2 into Y2 minus Y1. This spring is connected between M1 and M2. So while taking M1, we have to take it as Y1 minus Y2, and while considering M2, you have to take it as Y2 minus Y1. Now again we are going for the free body diagram of F1, and we are going to write the opposing forces and applied forces which is acting in M1. So opposing force due to the mass M1 is nothing but M1 into d square y1 by dt square. Here the displacement is y1, so d square y1 by dt square. Then Fb is nothing but b into dy1 by dt. Then Fk1 is nothing but k1 into y1, and Fk2 is nothing but k2 into y1 minus y2. By Newton's law, the applied force is equal to opposing force. Here the applied force is F of t, and the opposing force is Fm1, Fb plus Fk1. Fk1 plus Fk2. Now we are substituting these values and we are calculating the Laplace transform. Okay, we are applying the Laplace transform. Then we are taking y1 of s common from these two terms. Not these two terms, from these terms. This m1 into s square into y1 of s plus bs into y1 of s plus k1 into y1 of s plus k2 into y1 of s. From these terms you have to take this y1 common. Okay. Now we are going to find the opposing forces acting on M2. So free body, we are going for the free body diagram, and the forces is due to Fm2, that is nothing but Fm2 is equal to M2 into d square y2 by dt square. Here the displacement is y2. Then due to this spring, that is Fk2 is equal to k2 into y2 minus y1. Now we are by Newton's second law, opposing force is equal to applied force. Here in M2 there is no applied force, so m square plus d square y2 by d2 square plus k2 into y2 minus y1 is equal to 0. Now we are going for Laplace transform. So while taking Laplace transform, we are getting m2 into s square y2 of s plus k2 into y2 of s minus y1 of s. So from this we are calculating y1 of s. So we are calculating y1 of s from here. So after calculating y1 of s, we are going to the previous equation. While applying Laplace transform to the differential equation, what you have got from the mass m1, you are having this term. So here in this place you are substituting the value of y1 of s. So by applying the Newton's second law to the mass 2, we have got the value of y1. So from that we are substituting the value of y1 here, and we are simplifying and we are getting y2. So our aim is to find the transfer function. Here the output is nothing but y2 of s and the input is f of s. So after simplification you will be getting the transfer function as y2 of s divided by f of s is equal to k2 divided by m2 into s square plus m1 into s square plus b s plus k1 plus k2 into m2 s square plus k2 minus k2 square. Okay. This is nothing but the transfer function of the given problem. So finally we are going to write the solution. We are writing the two differential equation that we have got while applying the differential equation, by applying the Newton's second law, and after applying Laplace transform we are getting the transfer function. Okay. So this is the solution to that problem.